Hi everyone. Welcome to my Max Academy. We'll continue on the Polynomials chapter for 10th standard CBSE Max. We will continue with exercise 2.3, third problem. Okay, the third problem in exercise 2.3, page number 36. So page number 36, exercise 2.3. We'll continue on exercise 2.3, problem number 3. So what it says is obtain all zeros of the polynomial, right? The polynomial is, we'll call that as p of x, that is equal to, write the question number here, third question. P of x is equal to 3x power 4 plus 6x cube minus 2x square minus 10x minus 5. We have to find the zeros of, we have to find all the zeros of this polynomial, where the two of the zeros are given. What are the two zeros? Two zeros are given, which is root of 5 by 3 and square root minus 5 by 3. Root of 5 by 3 and minus root of 5 by 3. So two zeros are given. We have to find the remaining two zeros. Obviously, this is a polynomial of degree 4, so it will have a maximum of 4 zeros. This is exactly similar to example 9, which I did it in the previous video. Now two zeros are given. We have to find the remaining two zeros. So maximum this polynomial will have 4 zeros because degree is 4. So two zeros are given. We have to find the remaining two zeros. So solution is, so we know. So we'll take the given 0 1 as alpha equal to 1 0 as alpha, which is 5 by root of 5 by 3, and other 0 beta, which is minus root of 5 by 3. Beta equal to minus root of. Now we know. So we know this. If alpha and beta are two zeros of the polynomial p of x, if alpha and beta are the two zeros of p of x, then we can say x minus alpha into x minus beta is a factor of p of x, the given polynomial. So now, which means, what is x minus alpha? Which x minus, so we'll write x minus alpha and x minus beta. X minus alpha is x minus alpha is root of 5 by 3, x minus alpha into x minus beta. X minus beta is x minus beta is minus root of 5 by 3. So x minus alpha, next minus beta. Beta is minus root of 5 by 3. Is a factor of p of x. Right? Now let's multiply this. Then what do we get? So x minus root over 5 by 3 into x minus into minus plus root of 5 by 3 is a factor of p of x. Now what is x minus root 5 by 3? So we need to multiply. Either you can do normal polynomial multiplication, or we can use identity. This is in the form of a minus b into a plus b. A minus b into a plus b is a square minus b. B is root 5 the whole square. Right? We are using this identity. Just a plus b into a minus b is equal to a square minus b square. Right? So here a is x and your b is root of 5 by 3. So is a factor of p of x. So which means, what is this? X square minus root of 5 by 3 the whole square will give you 5 by 3. Right? Is a factor of p of x. So which means, see here we can try to avoid the fraction by adding this. So if you add these two, you'll get by 1. So you'll get 3x square minus 5 by 3. Right? So that can be written as 1 by 3 of 3x square minus 5 is a factor of p of x. See, this is just to avoid the fraction part. So we are writing, so if you add this or subtract this, so 3 into x square is 3x square minus 1 into 5 is 5 by 1 into 3. Normal fraction subtraction I am doing. I assume you all are comfortable with normal fraction subtraction. So so 1 by 3, if I take this 1 by 3 out, I'll get 3x square minus 5 is a factor of this, which means this 3x square, we can leave this number, this 3x square minus 5 is a factor of p of x, which means we need to divide this by this alone. Don't worry about this 1 by 3 fraction part, leave it. This is a factor of, which means this polynomial will divide this polynomial, given polynomial p of x exactly, which means the remainder will become 0. Let's do the division now, right? So I'll try to do the division here. So if we have to divide this, so we will write the p of x inside. So what is that? 3x power 4 plus 6x cube minus 2x square minus 10x minus 5. And here it will be 3x square, then there is no x term. There is no x term. So I should put 0x plus 0x minus 5. So don't worry about this minus 3. It's a number, so we don't have to get that here. We'll just, so this will definitely divide the p of x. Now if we divide this, what do we get? So we'll have to take the first term, 3x power 4 by first term of this by first term of this. 3x square, what is that? We'll get x square, so put x square here. So then x square into this, right? So x square into 3x square plus 0x minus 5. That will give me 3x power 4 plus 0x cube minus 5x square. So if I substitute that here, I'll get 3x power 4 plus 0x cube minus 5x square. Now change the sign. We are subtracting, plus minus, plus will become minus, minus will become plus. These two is called 6x cube minus x cube is 6x cube. Then minus 2 plus 5 is plus 3x square. Then bring down this minus 10x. Right? Then again, let's take this first term by this. So 6x cube by 3x square will give you 2x. Right? 6x cube. Right? So put the 2x here. Whatever you come get here, you get so plus 2x. Then 2x should be multiplied with this 3x square plus 0x minus 5. So what is that? 6x cube plus 0x square minus 10x. Substitute that here. What do we get? So we get 6x cube plus 0x square minus 10x. Fine. Now let's subtract minus, minus, plus. These two will get cancelled. 3x square minus 0x square is 3x square. Then minus 10 plus 10 is 0x. Bring this 5 down, minus 5. Now again take the first term and first term. 3x square by 3x square. Right? So I'll write here. So 3x square by 3x square gives me 1. So plus 1. So now 1 into this whole thing. So 1 into 3x square minus 0 plus 0x minus 5. That will give me 3x square plus 0x minus 5. Substitute this value here. So you'll get 3x square plus 0x minus 5. Then change the sign. Plus will become minus, minus, plus. So gone. Everything gets cancelled. Minus 5 plus 5. So remainder 0. Remember I told you, you must get the remainder as 0 because 3x square minus 5 is a factor of p of x. Factor means the remainder becomes 0. Now, so which means I'll cut. After this, I've written this continuation I'm writing here. Right? Please don't get confused. The continuation of this is now the given polynomial p of x is written as this one. 1 by 3 of 3x square minus 5 into this one. Into 3x square, sorry, into this, the quotient, I'm sorry, right? So it is written as this one, x square plus 2x plus 1, right? So this 3x square minus 5 into this. So the p of x is written this into this into this plus remainder. That is what the division algorithm says. Since the remainder is 0, your p of x is directly equal to g of x into q of x. So now we have written p of x as product of two quadratic polynomial. This one we know, this 3x square minus 5 will give you these two zeros, which is already given in the question. So we should take this and find the 0 of this polynomial. So how do you find the zeros of this polynomial? You will put this equal to 0, then factorize this. Get x square, splitting the middle term, x plus 1 equal to 0, x is common, x plus 1 plus 1 is common, x plus 1 equal to 0, then get x plus 1 is common, so x plus 1 equal to 0, you get x plus 1 equal to 0 or x plus 1 equal to 0, which means x is equal to minus 1 or x is equal to minus 1. So the remaining two zeros are minus 1 and minus 1. It is repeating two times, right? So, therefore what we can say is, we have found all the four zeros. So this is 1 0, 1 0, 2 0, third 0, fourth 0. So we can say the zeros are root of 5 by 3, minus root of 5 by 3, minus 1 and minus 1. Minus 1 is coming two times, right? So it's the same 0, minus 1 is coming two times. So totally there are 4, 1, 2, 3, 4. So we have found all the four zeros of this polynomial. Clear? So this is an important question from both point of view. It's an important question, right? So they'll give you some zero, they'll ask you to find the remaining zeros. So when with the given zeros, you will find a polynomial, and then you will divide the p of x by that polynomial. You will get another polynomial here. You have to factorize this polynomial and get the zeros, the remaining zeros. Fine. So now let's go to the fourth problem in this exercise. Erasing this. We'll do the fourth problem. So what is the fourth problem? Fourth problem is we have to use the division algorithm. So it says, on dividing x cube minus 3x square plus x plus 2 by a polynomial g of x, the quotient and remainders were x minus 2 and minus 2x plus 4 respectively. Find g of x. Then find the polynomial g of x. So the given polynomial, the one which we are dividing, that we call it as p of x. A p of x is given as x cube minus 3x square plus x plus 2, and this polynomial is divided by g of x, right? G of x is a polynomial which we have to find, right? And the quotient polynomial q of x is what? X minus 2, and the remainder polynomial r of x is what? Minus 2x plus 4. So we need to find the divisor polynomial. So when p of x is divided by the polynomial g of x, this is the quotient, this is the remainder. What is the g of x? What is the polynomial? What is the polynomial g of x? Which when it divides p of x, you get the remainder quotient as x minus 2 and remainder as minus 2x plus 4. So we will use our division algorithm. So what is our division algorithm? Division algorithm says that, so solution is by division algorithm. We have what we have. We have p of x is equal to g of x into q of x plus r of x, and we also have one more condition for the division algorithm that talks about the degree. That is okay. For this problem, we don't have to worry about the second part of that. Now, so p of x equal to 6. Now let's substitute all of. So I will write this as like this. This can also be written like this: g of x into q of x plus r of x equal to p of x. I can write this whole thing here and equal to it. I can write any either way. Now g of x we don't know, so I'll write g of x into q of x is what? X minus 2 plus r of x is what? Minus 2x plus 4, right? Equal to p of x is x cube minus 3x square plus x plus 2. X cube minus 3x square plus x plus 2. Now we need to solve this and find g of x. So g of x into x minus 2 equal to x cube minus 3x square plus x plus 2. I am going to take this here, this side. That's why I did not write here. I wrote only g of x and q of x. R of x I am going to take it to this side, right? So when it goes this side, it will become what? It will become minus 2x will become plus 2x plus 4 will become minus 4. So now if you simplify this, what do we get? X cube minus 3x square plus 3x minus 2, because x plus 2x is 3x, 2 minus 4 is minus 2. Right? Now what is my g of x? This is my g of x into x minus 2. So what is my g of x? My g of x will become x cube minus 3x square plus 3x minus 2 by x minus 2. This will come down. Right? So this is the value of, if you divide this polynomial by x minus 2, whatever polynomial that you are going to get, that is your g of x. And obviously that also should divide exactly. It will divide exactly because we have subtracted the remainder. Anyway, so we'll do the division of that. So what do we do? So we will divide. So x cube, x minus 2 is here. X cube minus 3x square plus 3x minus 2. Right? Make sure that all the terms are there. X cube, x square, x. Here also all the terms, and they are in the decreasing powers of x, which means x cube should come, then x square, x constant. Now take the first term of this, first term of this, same thing. X cube by x will give you x square. So I write x square, then x square should be multiplied with this. So x square into x is x cube, then x square into minus 2 is minus 2x square. Right? We generally do this, right? X square into x minus 2 is x cube minus 2x square. You multiply this with this, then whatever you get that, write it here, then change the sign. Minus, this becomes plus, cancel, minus 3x square plus 2x square will give me minus x square. Then bring down this plus 3x. Then divide this by this. So minus x square by minus x square by x will give me minus x. So I'll put minus x, then minus x into this minus x into this whole thing, x minus 2. That gives me minus x square plus 2x. So I'll put minus x square plus 2x. Then change the sign, plus minus, cancel, you'll get x. This comes down, x minus 2. Now again take the first term. So you will continue to do it. Don't stop here, because the degree of the r of x is not less than degree of g of x. Till that time you have to continue. So which means degree of this should become less than degree of this. Till that time it will continue. No, x by x. Divide x by x, which is 1. Now 1 into, so I will put that 1 here, plus 1, then 1 into x minus 2. 1 into x minus 2 will give you x minus 2. Write that x minus 2, then change the sign, cancel, 0. So this is your g of x. So when I divide this by this, using this, what I got? My g of x is equal to this by this, gives me x square minus x square minus x plus 1. So this is the polynomial which, when it divides the p of x, you will get the quotient as x minus 2 and remainder as minus 2x plus 4. So we have found the divisor polynomial, which is your g of x. Clear, guys and girls, right? So so this is the fourth problem which we have done now. Now we will do the fifth problem. Fifth problem is a little interesting one in 2.3. Fifth problem. So what the fifth problem says is, fifth problem is, we need to give examples for polynomials p of x, g of x, q of x, r of x, which satisfies the division algorithm and the condition given, right? So we have to find the polynomials p of x, g of x, q of x and r of x. 4 polynomials we have to find such that they satisfy the division algorithm, right? The division algorithm for polynomials, and also they should satisfy, there are 3 problems. First, under 5 we have 3, so they should also satisfy this condition, which is degree of p of x should be equal to degree of q of x. Like that we should give an example such a way that degree of p of x equal to degree of q of x. Now let's try to do some rough work here to find this. So suppose I want to find all of this. I want to find p of x, I want to find what is my g of x, now I want to find my q of x, and if I do this I will get r of x. Right? This is a skeleton of your polynomial division, right? The skeleton of polynomial division is, you will have a polynomial p of x, you will divide that by g of x, you will write quotient and some steps you will write, and finally you will get r of x. So we need to find these 4 polynomials, and they should obviously satisfy the polynomials, division algorithm for polynomial. Now how do we find these 4 polynomials, and then they must satisfy this condition also, which means my degree of p of x and degree of q both should have the same degree. Both should have the same degree. So when both have to have the same degree, suppose now I will write here, let me write here, now I am going to write that both of them should have the same degree. That is the condition it should satisfy. See, division algorithm, it should satisfy, that is the must, and in addition to that it should satisfy this condition also. So which means I will write, suppose if I put x square here, and I have to get x square here also, I have to get x square here also, then what I should have here, so that if I divide this by this, I get x square. I should put only 1, right? Which means x square by 1 will give me x square. What do we do? So just a simple polynomial we are taking. So I am taking p of x as x square, and I am taking my q of x, the degree should be same, because this means this is x square, this also should be x square. Degree should not change. Degree of this is 2, degree of this is also 2. So which means if I have x square, I have to divide x square by something. This I don't know. I have to divide x square by something. I will show that I get back the x square. So which means this should be 1. Clear? Now suppose, so which means if I take my, so from this what we understand is, suppose if I take my p of x as x square, and my q of x also should be x square, because both should have the same degree. So my g of x becomes 1. Now if you divide that, if you do the division of 1 with x square, right, 1 divided by x square, so I told you, you take the first term of this divided by first term of this. So x square by 1 is give you x square, that you will write as a quotient x square. Now you will multiply x square with 1, then I will get x square. Then we will change the sign, minus, so minus minus 0. So my r of x is 0. So this satisfies the division algorithm, because we actually divided, and also we have found that degree of p of x is also 2, degree of q of x is also 2. So we have found that this is an example of these 4 polynomials in such a way that they satisfy the division algorithm. Also the degree of p of x is 2, degree of q of x is also 2, which is match. We can have many number of examples. You can have something like this also. You can have, so this is one example, suppose A. One more example B, you can have your p of x as some 2x square, and you have to get in the q of x x square, or you can get 2x square also. So which means my g of x should be what? Right? Suppose if I write, let me erase this, I will write this again here. I'm just trying to, this may be little, you may feel like it is confusing little bit, but if you write more example, it will be clear. That's why I'm trying to give you another example. Suppose the same first question of 5th, I'm giving another example B. Another example is, I will take my p of x as 2x square. You can take anything. I can take 2x cube also. Suppose if I take it as 2x cube, then I will put my p of x here 2x cube. Then I know definitely I should get here x cube, because it should satisfy this condition. Degree of p of x should be equal to degree of r of x. Not always, but in this problem, this condition also should be satisfied. Then which means I should get x cube here also. Then with what here, with what I should divide 2x cube to get x square? So 2x cube by something should give me x cube. What should be this something? That is my g of x, which is 2. So 2 will get cancelled, I get x cube. So it should be 2. Right? Now 2 into x cube is 2x cube. So you will get the remainder as 0. Minus, change the sign, cancel 0. So the another example is p of x is 2x cube. Q of x is x cube. G of x is 2. And my r of x is 0. Right? Where your degree of p of x is equal to degree of q of x. And both are equal to what is the degree? 3. You can put anything. You can say 2x power 4, 2x power 4, then x power 4, then 2. Then remainder will become 0. Because if you divide 2x cube by 2, your portion will be x cube. The remainder will be obviously 0. Clear? So this is how. So you can give multiple examples like this. You can give multiple examples like this which satisfy the additional algorithm, and it should satisfy this condition also. Then second one is what? Second question for fifth, second part. Let me give an example again. P of x, Q of x, R of x, Q of x and R of x, G of x and all that, such that degree of, the condition is degree of Q of x should be equal to degree of R of x. Degree of Q of x should be equal to degree of R of x, which means degree of the quotient and degree of the remainder should be same. Like that we have to give an example of a polynomial. So what do? We will go with the skeleton. Suppose let's take any polynomial. Let's write something. I'll write only one term, x power 4, suppose. Now x power 4, I should divide by something, right, so that I get some quotient and remainder. Such that the degree of the quotient and degree of the remainder should be equal. And we know that degree of the remainder will be always less than the degree of the divisor. Right? Suppose if I put any value here. Suppose if so obviously I will try to put a value less than this, right? But I will put x square. Suppose if I put x square, what happens? What is x square? X power 4 by x square. I'll get x square, right? Oh, sorry, no, we will not put that. Sorry, we'll come again. So this is x power 4. The p of x is x power 4. Now I want my degree of R of x and degree of Q of x should be 0. Suppose I am getting the remainder as x. Suppose let's assume the remainder as x. Then I should get what is the degree of this x? 1. So I should get my degree of Q of x also 1. Suppose I get x here also. Suppose if I get the same x here also, the quotient is also x, remainder is also x, where the degree of both of them are equal. Now to get x here, x power 4 should be divided by what to get x here? So x power 4 by what? X power 4 by what will give you, question mark, will give you x. Obviously x cube, so I'll put here x cube. Now if I divide x cube by x power 4, I am getting x. Then I multiply x into x cube, I will get x power 4. Then I will get my remainder as 0. But I want the remainder as what? X. So I need to get the same remainder as the quotient. I mean, not exactly same, the degree should be same. So which means I should get x here. How can I get x here? I will put plus x here. Suppose if there is a plus x here, then what do? I will cancel these two. I will bring this x down. Then it will become x. Then this is x cube, this is x. The degree of R of x is less than degree of G of x. So I will not proceed. I will stop here. Now we have got the polynomial. So this is my P of x. So what is my P of x? My P of x will be x cube plus x. My G of x is only x cube. My Q of x is x. And my R of x is also x. So now what is the degree of Q of x? My degree of Q of x is equal to 1. And my degree of R of x is also equal to 1. So both are equal. So degree of Q of x is equal to degree of R of x. Clear? So we have given an example where, so we can have one more example. Let me give you one more. This may be little bit, you may feel like it is confusing, but if you write a skeleton of this like this, you will understand. I will give you one more example. Okay, let me erase all this. I'll erase these. Fine, a line. Okay, so I will give you one more example for the same problem. Fifth, second one, B. I'm getting B example. One more example. The same question, second question. And I'm giving another example. I'm calling that as B. This example we'll call it as A. Example A. I'm giving example B. So what it is? Now again, let's do the skeleton. So which means you can put anything here. Suppose if I put x power 5. Suppose I put x power 5. Now suppose I need here x square. Suppose I need x square. And the remainder also should be, suppose x square. And here I can't put x square because obviously if I divide x power 5 by x square, I will not get x square. So I will put x cube here. Right? X cube. Now if I divide my x power 5 by x cube, I will get x square. Right? We'll take this term, divide this term by this term. That's what we do, right? Long division. X power 5 by x cube will give you x square. That we'll put here. Then multiply x square into x cube is x power 5. Then we'll change the sign. Minus. So they'll get cancelled. We will get remainder 0. But we should not get the remainder 0. We should get the remainder as same as the quotient, which is x square. So which means I need an x square here. Which means I will put here plus x square. So that x square will come down. I'll get an x square in the remainder. Are you guys able to follow this? So it is as good as my p of x is x power 5 plus x square. My g of x is x cube. My q of x is x square. My r of x is also x square. Clear? So they will satisfy the division algorithm also, and also the given condition where degree of, here what is the degree of q of x? Here degree of q of x is 2. Degree of r of x is also 2. Degree of q of x is 2. R of x is 2. Therefore, so degree of q of x is equal to degree of r of x. So we have given an example where both the degrees are same. Right? And the last one is degree of r of x equal to 0. Degree of r of x is equal to 0. So again we can take multiple examples for this. Right? So degree of r of x is equal to 0 means so third part. I want degree of r of x is equal to 0. Degree of r of x is equal to 0 means what? R of x is a number. R of x I should get the remainder as 3, 5, 7, whatever. I should not get the remainder as 0. Degree should be 0. Degree should be 0 means my remainder should be any number other than 0. Any number other than 0. Now let's take some, let's suppose I have suppose anything x power 4. But I want the remainder as some number. I am writing the number here. The number is suppose 7. Any number. Okay, 7. Now let's divide this. Now I will write, suppose here I can take anything. I can put x or anything. I can put x square, anything. Suppose if I put x cube. Right? If I put x cube, or I can put x also. It doesn't matter. We'll take x. So if I put x, then x 4 by x is what? X cube. If I divide x power 4 by x, I'll get x cube. Then I have to multiply x cube with x. I'll get x power 4. Then if I subtract, they'll get cancelled. I'll get 0. X power I will get 0. But what I should get? I should get 7. If I need 7, you just put plus 7 here. That's all. You make your, then what will come? The sum will come down. Right? And we will not proceed further because degree of r of x is less than degree of g of x. We will stop. And what is the degree of r of x? Degree of r of x is 0 because degree of 7 is 0. Clear? So my p of x will be, you can take it as x power 4 plus 7. Then your g of x can be x, and your q of x becomes x cube. Your r of x becomes 7. And you can put anything. So let's take one more example. Suppose for fifth one, same thing. So suppose this is example A. Let's give one more example. Second example, I call it as B. So fifth, third, B example. Yeah, you can take the same thing. See, suppose again you put anything here, whatever you want. Suppose if I put same x power 4 here, or I want to put x power 5, x power 10, anything. So suppose if I put x power 10, right? Here I put anything that is less than this. X power 8 if I put, or you try to put probably one less than this. Even 8 is okay. Even you can put 8 also, doesn't matter. Right, now you divide x power 10 by x power 8, you'll get x square. X power 10 divided by x power 8, right? X power 10 by x power 8 will give you x power 2. Now x power 2 into x power 8 is x power 10. Now they'll get cancelled, minus, they'll get cancelled. I'll get the remainder 0, but I should give the remainder as some number other than 0. Any number. So I'll put, suppose if I want to get the remainder as 5, I'll put plus 5 here. Then this plus 5 will come down, that will become the remainder. So this is my p of x now. So my p of x becomes x power 10 plus 5. My g of x is x power 8. My q of x is x square. And my r of x is 5. So what we have achieved here, we have found the 4 polynomials and they will satisfy the division algorithm. You can check it. And then the important condition is it has to satisfy the condition that is given in the question, which is degree of r of x. Degree of r of x is what? Degree of r of x means, what is the degree of phi? Degree of phi is 0, because your r of x is 5. Phi can be written as 5 into x power 0. X power 0 is 1, right? So 5 into 1 is 5. So phi can be written as 5 into x power 0. And what is the highest power of the variable? You have only one term and the power is 0. So the degree has to be 0. When the degree of r of x is 0 means you need to get it as a number. Then you have to get that as a number. Not 0. You cannot have 0. Except 0, you can have any other number. Fine. So accordingly, you can put the skeleton and keep filling this, you will get this. Fine. So fine, we will stop here, and in the next video, I will be doing exercise 2.4, the optional exercise 2.4. Thank you.